For question 1.2, we've been given two box and whisker plots for the 16 learners that wrote two tests, and we are asked to describe the skewness of the marks for test 1. To assess skewness, we need to look at which half of the box and whisker plot is longer. So if your left half of the box and whisker plot is longer, then it's skewed to the left. If the right half of the box and whisker plot is longer, then it's skewed to the right. So we're going to assess that for test 1 over here. Okay, so the left half spans from 26 to 62, and the length of that will be 36. You just say the big one minus the small one to get the length. And the length of the right hand side of the box and whisker plot, if I say the big one minus the small one, the big one minus the small one, I get 32. So we can see the left hand side is slightly longer, which means that the data in test 1 is skewed to the left. Okay, and then your 1 mark purely just comes from that word there, left. You can also say negatively skewed, but I like sort of knowing it's to the left so you can see it more visually. And now we need to determine which test was easier for the learners. Give a reason for your answer. Now, something you need to know about box and whisker plots is that it divides the data into quarters. So each little division on a box and whisker plot is 25% of your sort of data sample. So this one, even though it's not as long as this one, it's still 25% of the people are sitting in this data region. So if we kind of put that to the test here, then we can see that half the learners in test 2 got above 66. But in test 1, half the learners only got above 62. So the learners must have found test 2 easier in this case. You can also compare the medians. So how we write that up is we actually need to answer the question first. Which test was easier for the learners? Test 2. And then as our reasoning, to give a reason for our answer, we say 50% of learners got marks above 66 in test 2, while only 50% of learners got above 62 in test 1. And a shortcut of saying that is the median of test 2 is higher than the median of test 1, because this line over here is representative of the median in a box and whisker plot. And then 1 mark will come from this, and 1 mark will come from either one of these reasons. And the last question on the box and whisker plot for this paper: how many learners scored above 84% for the second test? So we're going to ignore test 1. And we're going to find 84% and see where it lies on test 2. So 84% will be in between these two blokes, so it's over here. And we want to know how many learners scored more than 84%. So it's 84 onwards this way. Because if I go that way, they scored lower than 84%. So we want to know how many learners are over here. And to do that, we need to use this number, 16 learners. And we also need to know how a box and whisker plot divides our data. So thinking back to the last question, each one of these segments, Q stands for quartiles. A box and whisker plot divides things into quarters. And a quarter in terms of a percentage is 25%. So in this little whisker over here, we've got 25% of the learners. So I'm just going to take 25%, multiply it by that 16, and it will tell me how many learners are in here. So 25% of 16, just pop that into the calculator and you get 4 learners. Bear in mind, instead of saying 25%, you can represent it as a fraction or a decimal. So I could have done this. 0.25 times 16 gives me the same outcome. I could have done this. 25 over 100, because percentage just means per 100, which means a part over 100. Or I even could have done this. A quarter times 16, because box and whisker plots divide things in quarters, Qs. And your 2 marks come from your working out, you get 1 mark there, and the final answer, you also get 1 mark there. And that wraps up the box and whisker plots for this paper.